Hi guys, so here we're going to talk about something called molar mass. You'll need your notes, a calculator, your periodic table, and then you also need your stoichiometry notes from Unit 3. We'll need the mole map, and I had you guys copy this down, so it's mole map. If you don't have it, it's the Unit 3 video on stoichiometry. We can also do it here as well. So the mole map. We have a mole of either two substances, and we can use something called a mole ratio, which we'll use later on in Unit 4. We can convert to and from liters of a gas at standard temperature and pressure using the number 22.4 liters to equal a mole. We can also use grams of a solid, and this is when we definitely need to look at states of matter. So the liters of a gas at STP, the 22.4, again, a gas. The red one is the mass from the periodic table, which we'll do today. The number of particles is 6.022 times 10 to the 23rd. And if we have a solution, so an aqueous solution, something mixed in with water, we'll use something called molarity, which is moles per liter. So for today, we're just really focusing in on how to determine what this is. Super simple. As long as you can multiply and add, or at least have your calculator, it'll be easy for you to do. Right? So molar mass, it's pretty much the mass of a compound, or at least 1 mole of that compound. So 6.022 times 10 to the 23rd particles of it. So you just add up the atomic masses in the periodic table. You might also see it called gram formula mass, which is GFM. I've also seen gram molecular mass, GMM, and the units are grams per mole. So we'll use the periodic table, and here we want to make sure that we just look at the numbers for the atomic mass. So using the key, it's the number in the upper left-hand corner. Okay, so any of those numbers up there. Yes, some of them have a lot of numbers after the decimal point, and that's okay. We'll put all of them in for accuracy's sake or precision. Alright, so here's some examples. We have CO2. Now we have to figure out or count up how many elements we have in here and how many of each. So I know I have 1 carbon and 2 oxygens. So I'm going to add up the masses of each. So I'm going to take 1 carbon, and the mass of carbon, according to the periodic table, is 12.011. Oops. And I'm going to add that to 2 oxygens. And I know this from the periodic table is 15.9994, and add that up. So when you punch this into your calculator, well, we don't need to bother with a 1, because anything multiplied by 1 is itself. So put in 12.011 plus, and then here's when parentheses are your friends. Use 2 times 15.9994, and go ahead and punch that in. So here, you should get 44.0098. We'll squeeze that in. And if I make any mistakes on here, guys, just come see me tomorrow. I'm sure that I probably will make some mistakes, so it's okay. So, for number 2, I have C2H5OH. I'm going to count up how many of each element I have. So I have 2 carbons. I have 5 hydrogens here, but I have 1 more right there. So I really have a total of 6 hydrogens and then 1 oxygen. So I'm going to add all of those up. This time I'll put the parentheses or the numbers inside. So I know carbon is 12.011. And by the way, you'll start to memorize these. It'll be kind of scary and cool at the same time. Hydrogen, look that one up. That's 1.00794. And then we add that to 1 oxygen. And I don't really need to put that 1 there, but I'll put it there just so you see it. So that's 15.9994. Go ahead and type this into your calculator using the parentheses. So for this, I should get 46.06. Oopsies, there's 6904. And of course, we need to make sure that we have units. So that's grams per mole. And I forgot to put units in the last one, sorry. Here we go. Alright, so for this next one, we have MgClO32. Here we have parentheses, so you need to make sure that you put those parentheses or kind of know how to distribute all the numbers inside. So I know I have 1 magnesium, and here I have Cl. There's an imaginary 1 there, and of 2 outside. So I multiply that 1 times the 2, meaning I have 2 Cls. Add those together. And now I have 3 oxygens inside, and I'm multiplying it by the 2. So now I have 6 oxygens total. Look at the atomic mass off the periodic table. So I have 1 magnesium. Magnesium is 24.305. 2 chlorines. Let's see, chlorine is 35.453. That's a decimal. Add that to 6 oxygens. 6 times 15.9994. Go ahead and punch that into your calculator. Alright, so when you add these all together, multiply and add them together, you have 191.2074, and again the units are grams per mole. So here we have Al2, and then in parentheses we have CrO4, and outside the parentheses we have a 3. So for Al, I know that I have 2 aluminums, and then looking at the rest of it, I have 3 chromiums, and then inside the parentheses are 4 oxygens, and then outside I multiply it by the 3, so I end up with 12 oxygens. So let's look up the molar masses, or excuse me, the atomic mass from the periodic table. So I have 2 times 26 point, that's a 9, it's kind of hard to read, 98,154, and then chromium 3 times 51.996, and add that to 12 oxygens, 15.9994. So put that into your calculators. You end up with 401.94388. Again, it's grams per mole. So, kind of thinking about this, 6.022 times 10 to the 23rd particles of aluminum chromium would end up, if you put that onto a scale, it actually ends up being 401.94, etc. grams on the scale. So the next thing I have here are something called hydrates. So you've seen this dot before in math. Here in chemistry, it means that we're going to be adding in the numbers. Pretty much what this means is if this were CaSO4 molecules, if I had a particle diagram of these, I would end up having, for every 1 CaSO4, I'd end up having 2 waters, and the blue ones are representing the waters. Kind of embedded all around. Alright, so this is what this is called a hydrate. So I'll erase all of that. And let's kind of go through how to put these together. So I know I have 1 calcium, I have 1 sulfur, and in the beginning part I have 4 oxygens. And then I have a coefficient in front. So that coefficient, you'll also multiply it by the subscripts. So here there's 4 hydrogens, and 2 times the imaginary 1 there means that there's 2 oxygens. Now if you want to put those the 4 oxygen here and the 2 oxygen there together to make it 6 oxygen, that's fine with me. I'll show you what it looks like outside of that or otherwise. So it's 1 calcium. The calcium is 40.08. We also have 1 sulfur. That's 32.065. 4 oxygens, 4 times 15.9994. I'm running out of room here, so I'm going to just put it down to the side here. 4 hydrogens, which is 1.00794. And 2 oxygens, 2 times 15.9994. And I kind of intermixed the multiplication, using the parentheses. I'm putting them into the parentheses here just to show you how to put them into your calculator. So it'd be, you can get rid of that 1, get rid of that 1. So it's 40.08 plus 32.065, and then add them up. add in a parenthesis, so 4 times 15.9994, close out that parentheses, put a plus sign, make a new parenthesis, open up a new one, 4 times 1.00794, close it up, add another one, and then another parenthesis, 2 times 15.9994, and close up that parenthesis, press equal, and when you do, you should end up getting, at least I got, 172.17316 grams per mole. Oops, there we go. And again, if you see any errors in here, just let me know in class, because I'm sure you will. I happen to have my phone with me. I forgot my calculator at school, so you know how I always say don't use your phone because you make mistakes? Well, I probably made some mistakes in here. So I have, for number 6, 1 copper, 1 sulfur, I have 4 oxygens here, and then my new hydrate here, so I'm making that a plus sign, or I'm essentially adding in the masses. It's 5 times 2, which is 10 hydrogens, and then I add 5 times that imaginary 1, so it's 5 oxygens. So here I'm actually, just for space's sake, I'm going to put these two together to make this 9 oxygens, so I can ignore that. Alright, so look up the atomic masses. 1 copper is, or 1 mole of copper is 63.546. 1 more mole of sulfur is 32.065. And adding them up. And I have 9 moles of oxygen, so it's going to be 9 times 15.9994. I'm sure you've probably memorized that one by now. And then 10 hydrogens, so 10 times 1.00794. Put that into your calculator, add them up. I ended up getting 249.685, and that was grams per mole. Okay, so for molar mass, you just take the masses from the periodic table, and just a word of wisdom, look out for any of those parentheses and those hydrates, so those dots with water on the right-hand side. They can mess you up sometimes, so make sure you just take a look at them just to make sure that you have them. Let me know if you guys have any questions, and we'll practice this a lot during class, so no worries. Take care.